Hello there, Mr. Sutton here, bringing you the Algebra 2 6-4 Part 1 homework solutions on transformations of exponential functions. For this problem, we're trying to transform the f function. Let's first identify the transformation. Since we have this plus 2 happening inside the exponent, inside the function here, that's going to be a horizontal change, so it's going to be left, right, and opposite of what we expect. So this means minus 2 for the translation. It's going to be a left 2 shift. The minus 2 outside the function is shifting us down by 2. So we've got left 2 and down 2. Let's write the parent table using 2 to the x. Since this is a growth function, we're just going to go from -1 to +2 for my x values. So we've got 2 to the -1 is 1/2, 2 to the 0 is 1, 2 to the 1 is 2, and 2 squared is 4. For the new rules here for the g function, since we're going left 2, we have to do x minus 2. And since we're going down 2, we have to do y minus 2 as well. Let's go subtract 2 from everything now. -1 minus 2 is -3. Then we have -2, -1, and 2 minus 2 is 0. Next, let's subtract 2 from all the y values. 1/2 minus 2 is going to be -3/2, or -1.5. 1 minus 2 is -1, 2 minus 2 is 0, and 4 minus 2 is 2. All right, graphing this all out, we've got -3, -1.5 right about here, and then -2, -1, -1, 0, and finally 0, 2. Now normally we have an asymptote for this exponential function on the x-axis. Since we shifted down 2, that means our asymptote is also shifted down to y equals -2 right here. Now we can draw a curve with that and the points that we've done. So here's our exponential function. For this problem, the transformation that's happening here, the parent function is e to the -x. So the transformation, we're just adding 6 outside the original function. So that's going to be a translation of up 6. So let's do the parent table for e to the -x. We're going from -2 to 1 because this is exponential decay. This is really 1 over e to the positive x. And let's plug all that into Desmos now to get a few decimal values to help us out here. So let's see. Let me do f of x equals e exponent -x, and then I can just plug things into that. So f of -2, we've got about 7.39. f of -1, that's going to be 2.72. And then let's see here, e to the 0 is 1, and e to the -1, if we plug +1 in here, it'll be e to the -1, which is about 0.37. So now I'm going to go ahead and apply the rules here to get a new x and y rule. Since nothing's happening horizontally, x is going to stay the same as it was. But for the y values, we're going up 6, so we have to do +6, y +6. Let's keep the x's the same, so -2, -1, 0, and 1. But now we're adding 6 to all these y values, so 13.39, 8.72, 7, and 6.37. I didn't even need a calculator for that. All right, so let's graph these out. I'm going to go by 2's on my y values just to be able to get all the way up to 13.5 roughly. So we've got -2, 13.39. That's roughly in this area. -1, 8.7 is somewhere almost halfway. And then 0, 7 is right here. And then 1, 6.37 is somewhere over here. Now, since I translated up 6, that means my exponential function asymptote that's normally on the x-axis is also being shifted up 6. So I have to draw the asymptote here at y equals 6. And then this is a decay function, so we're going down like this through those points and approaching that asymptote. On this problem, we're transforming the e to the x function as indicated by the g function. In terms of what's happening, we're multiplying by 2 inside the function, so that's going to be a horizontal shrink. It's opposite of what it looks like. Let's do our parent function now for e to the x. And since that is exponential growth, since e is about 2.7, it's bigger than 1, that means we're going to be going from -1 to 2 for the x values. So let me just plug all those into Desmos, or at least a few of them. So let's do e to the -1 to get that first value, and that's about 3.7. E to the 0 is just 1. E to the 1 is about 2.72. I know roughly the value of e. And then we need e squared, which is about 7.39. Now to transform this into the g function, since I'm multiplying by 2 inside, that means I have to multiply by 1/2 for my x values. And there's nothing happening outside the function, so y is going to stay the way it is. So dividing all my x values by 2, we've got -0.5 or -1/2. 0 is still 0. 1 is 1/2, and 2 becomes 1. And then the y values are just going to stay the same. So we got 2.72, 7.39 rather. There we go. Graphing all of this out, we have -1/2, comma 0.37, which is roughly here. 0, comma 1 is right there. 1/2, comma 2.7 is about there. And we have 1, comma 7.3 and some changes somewhere up here. We didn't shift things vertically at all, so my horizontal asymptote on the x-axis is still there, and I can just draw an exponential function that approaches that and goes through these points. On this problem, I'm trying to transform the 3/4 to the x function. So what's going on with this g function? Well, we have a negative outside the function. That gives us a vertical reflection. And the -7 inside the exponent is giving me a 7 shift to the right. The +1 outside is shifting us up 1. So vertical reflection and translations right 7 and up 1. To get my original f function, I'm just going to plug -2 through +1 into this. Since it's a decay function, I start with -2 and end with 1. So let me go to Desmos and plug a few of these in. So let me write the f function. F of x equals parentheses, fraction 3/4, raising that to the x power. And now let's plug in -2. That's about 1.78. And if I plug in -1, well, that would just give us 4/3. So that's about 1.33. If I plug in 0, anything to the 0 is going to be 1. And if I plug in 1, 3/4 is going to be 0.75. So I didn't really need the calculator for most of that at least. But let's see what the future holds here. So now for my g function, since I'm translating right 7, that means I have a new rule of x plus 7. And the vertical reflection in the up 1 means I'm going to need to do -y and then a +1. So let's add 7 to all our x values to start it here. -2 plus 7 is 5, -1 plus 7 is 6, then we have 7 and 8. And now let's do -y plus 1 for all of these values. -1.78 plus 1 is just 0.78, or -0.78 rather. -1.33 plus 1 is now going to be -0.33. -1 plus 1 is 0. And -0.75 plus 1 is now going to be +0.25. So for my axes here, I'm making my y values go by 0.2s just because I don't have a lot of movement going on there. And then I'll shift this a little bit over to the right in terms of how much I'm showing here because I've got these right shifted kind of values. So we've got 5, -0.78. That's roughly 0.8, which is about here. Next we have 6, -0.33, which is roughly here. 7, 0 is pretty easy to do. And then 8, let's see here, 0.25, that's about right here. Since I shifted up 1, my horizontal asymptote that's normally on the x-axis is also shifted up 1. So that's going to be all the way up here at y equals 1. So I'm going to follow these and just kind of head in that general direction. We're not going far enough to the right to really see it approaching the horizontal asymptote, but we'll settle for this. On this problem, I'm trying to write a rule that transforms f of x as they mentioned here. Vertical stretch by 4 and a translation 1 unit up and 3 units to the left. So I'm going to handle each of these transformations with a different function, one at a time. First, let me create a g function that stretches this vertically by 4. So I'm going to write g of x equals 4 times the f function, which is going to be 4 times 8 to the x. And I can't simplify by multiplying these together, so this is just what the g function is going to be. Next up, if I'm translating up 1, I'm going to create an h function that does g of x plus 1. And if I'm translating 3 left, I'll actually also throw that in there. I'll do x plus 3 in here to go left 3. So when I plug all this in to my g function, I'm going to have 4 times 8 to the, and now the new exponent is this x plus 3, and then we just have this random plus 1 hanging out here. On this one, I'm trying to transform the e to the x function following these directions. So we're going to create a couple new functions, one for each of these transformations, and we'll just take it a step at a time. First, I need to do a horizontal shrink by a factor of 1/2. So I'm going to make a g function that does that. G is going to equal f of, and since it's inside, and it's going to be opposite of what we expect, so instead of doing 1/2 times x, I actually have to do 2 times x to do that shrink. So we have f of 2x. Now applying that to the e to the x function, that means we have e to the 2x. Next up, I need to go up 5. So I'm going to make an h function that basically does g of x plus 5. So that's just e to the 2x plus 5. And then that's our final function.